So the group 3 parts are all low in height and pretty easy to solder on, and they're one of, so they fit only in the footprint they're intended for. So there's capacitors and there's resistors. Now the resistors, you've got 1Ks and 10Ks, and their marking I'm going to explain to you when we get to them. There's also these LEDs, and you've got to watch how you solder those because they're pretty soft. Now they've got a green mark at one end, and that's the bar on the LED, and that needs to line up with the bar at the end of the footprint. So I'm going to start the resistors and capacitors by going around and putting a little bit of solder on one pad and then placing those parts down. All the capacitors in group 3 are 0.1 microfarads, and they're a medium brown color. They're in the long strip of unmarked capacitors. The part marked O1B is a 1K ohm 1% resistor. Let's just talk about how those parts are marked. When they brought out surface mount resistors, they decided to use a number code to identify the value instead of the old color bands. Now the numbers that they use are basically a straight copy of the old color bands, so you read the code the same way. So here we have a resistor marked with 223, and the way that you would read that is you would say it's 22 times 10 to the third. Now one of the ways that I've learned it's easier to read is I would just say that is 22 and 3 zeros, which makes it 22K, which was the value of this resistor here. And that applies to a 5% or a 10% resistor. Now when you go into 1% resistors like this one here, you've got values in between, so now they've got to specify the third digit. So in a 1% resistor, you would have 820 as the magnitude, so it would be 820, and then it would be times 10 to the 2. Again, it works if you just go 820 and 2 more zeros, and that is 82,000 ohms. So you can read it either way. Now for less than 10 and less than 1 ohm, sometimes you'll see an R in between there. So this one here is 4R7 or 4.7 ohms. So the R represents a decimal point in this system. And here this is less than 1 and it's using the same system. The R is a decimal point, so that is 0.22 ohms. And then you'll have a 0 ohm resistor. You can see that marked a couple different ways here with a single zero or with a couple zeros. Now a 0 ohm resistor seems counterintuitive. What they use that for is a short or a jumper in a circuit. If you want some configuration options on a product where when the microprocessor wakes up it reads the value on a port and then it knows what the product ID is, you can use 0 ohm jumpers in that application. As the parts got smaller, it became more difficult to squeeze 4 digits onto an 0603, and so they came up with a 3-letter code for the smaller surface mount parts. So now this is all for 1% resistor values. This does not apply to 5% or 10%. And essentially what it is, this is no longer a value here, these first 2 digits. It is a code that you look up in a table. So 01 you look up in the table here, and that would be a 1K. Now don't get the idea that the 01, oh well then 02 is 2K and 03 is 3K. That is not correct. If you look at something like the code 32 here, it's a 2.43K ohm resistor. So the first 2 digits have really nothing to do with the value. So a 52 is a 3.4 and an 84 is a 7.3. The first 2 digits are just a code. So the third digit, which is a letter, and in this case it's a B, that represents a range. So the B resistors are basically the Ks of ohms, and they go anywhere from 1K up to 9.76K. So that's how you would recognize a resistor that's in the K ohms. It used to be H. You may see some resistors with an H on it. Those are also in the K ohms. Now something with a C, that's the next letter in the code, and something with a C on it would be the tens of K ohms. So an O1C is a 10 K ohm. So note the O1 basically puts it in the same point in the table, and then the C is generally used as a multiplier. Okay, I'm just going to speed this up a little bit as I solder down one side of these resistors. So be very careful with these LEDs. The clear plastic has a low melting temperature, and if you touch it with a soldering iron, you will melt the top of them. And this one here, I think I'm putting this one in backwards. The green arrows are not aligned with the bar. I think I fixed that up after. So now I'm going to go back and I'm going to recenter these parts a little bit better, and then I'm going to tack down the other side and try and clean them up. So we'll speed up through this part. So if you're not satisfied with the way the solder joints look at the end, you can always go back and put a little bit of flux down on all the joints. And then what you do is you come in with the iron and you just touch it with the iron, and they'll reflow and they'll give you that really smooth, shiny look. That tells you you've got a good solder joint. And that's about it. We'll move on to the chips.